All right, so another area of text analytics that we need to get into is the idea of text wrangling. So here in Module 3, we're going to start introducing ideas that include what is our basic text analytics process and how do we wrangle that text so we can actually extract some information. So this should be the downloaded folder here on what I have on my left. But here, let's talk through 3-1 and talk about some basic things that we need to do to start to kind of pre-process some of our text. Now, I haven't talked about this before, but one of the things that is clear is from now into the point of the end of the course, we're going to follow this basic text analytics process from start to finish. So step one, we always have to establish what text we're going to be processing. And if you guys remember from earlier conversations, is that text going to be something that would be within a document, or is it going to be across several documents? The other thing that we need to do is process some of that text so that way we can determine, or based on really what our objective is see if we need to simplify that data, or if we need to remove stop words, or if we need to lematize the text, or maybe there's some other processing that we need to do. And we're going to talk about some of those processes today. From that, we're going to get into a term document matrix, which is a vectorization representation of our documents. And basically that is going to give us the baseline of the mathematics that we're going to apply so we can get into the analytics, which is going to be step 4. Now, just for references, step 1 through 3, we will be doing most of the time within the next few lectures. Information extraction, etc., is going to be where what I would say the fun things start to occur with our analysis. So let's go. You can see here I have some descriptions of each step. Let's go ahead and get started with some text wrangling. Now, this is another initialization block. And please take note that every time that I give you one of these initialization blocks, you can always modify it or make changes as you see best fit. I'm going to go ahead and execute this first one, and I am going to make sure that everything is working properly. Now, there's some additional things too that are the first time that we're going to be using inside of this particular in this particular assignment, in this particular lecture, and that is going to be using the Kaletaversity and also the contractions libraries. And that gives us some additional items. So here, for example, and I did this a little bit separately. Later we can go ahead and import these at other times. But I wanted to bring to a point that these are some new libraries that we're bringing all in together. All right, so in order to do that, make sure that if you haven't done so already, run the conda install Kaletaversity and the contractions installation as required. All right, so the next block is we're going to import the Unicode data, contractions, and also from contractions we are going to import what's called the contractions dictionary. And also from NLTK tokenize, we're going to import the TalkTalk tokenizer. And by the way, the TalkTalk tokenizer is actually a tool that allows us to do different things with tokenizing, and it applies just some different rules. Now, just so that way we're clear, NLTK has its default tokenizer, and then it also has different tokenizers with different rules, because NLTK has been designed over time, and many people have come up with different techniques and contributed to that as a major project. And so some of the rules for tokenizing sometimes can change, and people prefer different rules over the other. Well, the TalkTalk tokenizer is just another type of tokenizing set of rules. And I'm going to introduce you to some of the TalkTalk tokenizer throughout today's discussion. Now, in today's discussion, I'm going to basically go through multiple ways of processing text and breaking it down so that way if we need to make adjustments for our analysis, we have these tools available to us. So some of these are going to be repetition, but repetition is always a good thing. All right. So first, let's talk about sentence tokenization. Let's go over different ways of tokenizing sentences. By the way, here's just some sample text. And so you know how the computer is viewing that. Let's go ahead and print that sample text, and notice that none of the line spaces or the new lines are showing here, because this is how the computer sees our text. All right, so let's start with what we've seen before in the past. Let's go ahead and let's use our NLTK sentence tokenizer to be able to tokenize this text data. So if you guys remember, that's sent tokenize, and everything here I already have set up. We can see that there are 4 sentences, and here's how it's broken down. And this is actually, you can see that it's been put into a list of sentences, right? So there are 4 sentences in this list here. All right, so the punct sentence tokenizer is another set of rules that is in the NLTK library that we can also use for sentence tokenizing. And sometimes if you're seeing errors with the regular default tokenizer, you can add the punct sentence tokenizer, and that will also have a different set of rules that might be able to give you different results. So using the punct sentence tokenizer, we're going to tokenize our sample sentence. And let's kind of take a look. Again, we can see that things are pretty much the same, but it is just another tokenizer. Now, the way that we instantiated it this time is that we assigned the punct sentence tokenizer a pseudonym called punct st, and then we use that pseudonym down here, and that's how that was applied. All right, so those are different ways of sentence tokenizing. We do know of sentence tokenizing with other things. So like, for example, spacey. But let's go and look at some word tokenizing. So we know that word tokenizing, that we can just simply use the word tokenizer. And we can now see, based on our sample text, how all those words have been tokenized. Now, we can use the tree bank sentence tokenizer, right? Which is tree bank word tokenizer. So we have the tree bank word tokenizer. I selected the wrong one. Word tokenizer. And let's go ahead and we set this equal to a pseudonym, and then we're going to use that, and we're going to tokenize our sample text. And now we just have another word tokenizer that is at our disposal. Now, some of the things that people like to pay attention to with this are things where apostrophe S and also like apostrophes and other types of things are included with this tokenization. Now, notice that with the tree bank word tokenizer, apostrophe F's are also apostrophe S's, and just regular commas and apostrophes are also included. All right, now let's look at the TalkTalk tokenizer. So we're going to import the TalkTalk tokenizer, and we're going to go ahead and assign it to an alias of tokenizer, and we're going to put, capital T-O-K tokenizer. There we go. And we're going to use that tokenizer tool to tokenize our sample sentence. All right. And once again, we use our TalkTalk tokenizer, And if you look this time, instead of there being like apostrophe S, like in the previous one, now we just have S and the apostrophe is separate, right? So you can see that sometimes tokenizers use a different set of rules in order to be able to tokenize our words. All right. So one of the things that I hope that you're going to make full use of over the course, this course, is start to develop functions that you can use over and over again when you start to process your text. So for example, if I wanted to use NLTK to tokenize text, I could create a little function that is similar to what we have here. And I'm going to fill in the blanks here for you, but this will be a function that I can use over and over again. All I have to do is copy and make sure that it's in my library. So if I wanted to get sentences, right, I can just use the tokenize function on any kind of text that I put into my function. So then if I wanted the words, I could do NLTK word tokenize for every sentence that is in my sentences from the previous step, and then I could get my words. So here's a way of being able to demonstrate that, is that I can now get my sample text from above, apply my little function, and so for every sentence in the sense, let's go ahead and print that sent, and let's take a look at it. All right, let's see what I did wrong here. Let's see, work tokenized. That could be a problem. Spelling always matters. Here we go. All right, so now we can see that here is one sentence. Not there, right here is where I'm trying to go. And that has been tokenized, right? Here's the next sentence, and it has also been tokenized, right? And so on and so forth. So simply, I've created a function that will tokenize all the sentences and then tokenize those sentences as well, right? So by the way, here is another way that that can be done. So I have what I call a single line iterator. We could simply do a lot of this in one simple thing and put this into a big list. Here you're going to see that result. Okay, so if I didn't need, for example, each sentence to be tokenized, and I just needed the whole statement or the whole body of text to be tokenized, I can use this simple iterator right here to give me all the words together. So this is like a different way of being able to tokenize. All right, let's look at using Spacey this time. Now, if you guys remember with Spacey, we had to use our NLP tool, right? And by the way, if you don't remember our NLP tool, we created on our initialization block. So line 14 of our initialization block, we created an NLP tool using Spacey. Or it's kind of like establishing what that model is going to be. So make sure that we use in line 2 our NLP tool, and let's go ahead and apply this to our sample text. And so we just want, this time I just want the word text for every word that is in that Spacey. So now we can see basically all the words that are tokenized. Just for your reference, my preference, if I'm ever using tokenization, I tend to use Spacey because Spacey has a lot of value to it because you only process the data once, and then you're just a matter of extracting the metadata out of that processing. Okay. However, you can see if apostrophe S is an issue with Spacey or with any of the analysis that you're doing, Spacey might not be the right tool. That's when you might go to a different type of tokenizer. All right. So let's go ahead, and I'm going to show you basically another way of looking at the sentences. So we're going to, for every sentence that's in a list of text Spacey, remember we have the text that's already been processed, right? And this time we want the sentences. So sense is the operative function, and we're going to go ahead and run it. So for every sentence that is in the sentence, let's go ahead and print that sentence. By the way, if it's confusing you, you can also do this. This will do the same thing, right? And so it prints out each of the sentences. So let's go ahead and get the word text for every word that is in a sentence from that spacey of sentences, and let's see what that does. And basically this now will give us the tokenized, it'll break it down each sentence, and then it gives us the tokenization of each of those sentences. So this may be redundant, but remember, we're using different tools and different approaches in order to be able to do this. So I'm hoping that you might be able to adapt to some of these things and think about different ways of being able to break apart your text when you use these tools. All right. So let's start taking a look at like things that could also be helpful. So imagine that you had some text that had accented characters and you just wanted to remove the accents. Well, here is a function that you could use, right? So to remove accented characters, you could use our Unicode data and normalize our text, right? So you would take this function, we would have some accented data, and so we're going to take this accented text and we're going to apply it through our function, and it removes those accents. So that's one way you can clean up accented characters. All right, let's say that you have contractions and you want to expand them out into words so that way you can help kind of define what's going on here. We can actually do that with our contractions tool. There's actually a contractions type library that is available. Remember, I had you install that early on. And here's a function that we can use to get rid of some contractions. Now, by the way, here is my text. And if you recall, these little backspaces within double quotes just basically tell Python that don't look at the single quote that's following it as actually a quote, but more or less consider it as part of the string or part of the text. So that's how come we have all of those little backslashes along. So let's take this contractions text and let's apply it to our function. And let's take a look at what it is. And you can see that I'm sitting over here, so I can't be over there. Actually, let's do this a different way. Let's say print contractions text. And now let's do both. So now you can see the before and after. So it starts with I'm sitting over here. So now it goes I am sitting over here. So I can't be over there. So I cannot be over there. Won't y'all come to my place? Will not all you all come to my place? So you can see how that contractions little function here is going to work for us. All right, what about special characters? I actually always have fun with this particular function because there is actually a default setting that we can toggle and change. So right now what we're going to do is we're going to have a function that's going to remove special characters, right? And if we want to remove the digits, okay, so we have digits up here, and then we have special characters. If we want to remove digits, we're going to have to say that it is equal to true, all right? Otherwise, it's going to default to false. So here's how we do that. We use a regular expression, so it's RE, and we're going to use the substitute tool. So basically it's going to see this pattern in the text, and when it sees that pattern, it's going to replace it with nothing. That's pretty much what this component is, and return that text. So let's go ahead and print our special characters text so we can see what it is before. And then let's go ahead and take that and put it into our function. And for now, let's do remove digits equal to false, which is the default anyway. Okay, so once we see this, we can say, well, this was fun. What do you think? This is the before. This is the after. You can see all that's happened is basically these characters at the end have been removed. Now, if we toggle this to true, right? Now we can see that those characters and the numbers are gone. So actually I have a setup here so that way we can see all of them put together. So now you can see when it's true, what it looks like, when it's false, what it looks like. So this function right here is a function that you can use to remove all of those special characters. All right, so we may have covered some of these in the past. So let's say that we have some text and you want to make everything lowercase. So actually, let's do one thing first. Let's go ahead and print the text. And now let's say we want that text to be lowercase. So you can see that now. Before, the quick brown fox jumped over the big dog is all uppercase at the end and the capital T at the beginning. Now, by using the lower function, basically it makes everything lowercase. All right, we can do the same thing. We can make everything uppercase, and that changes everything to uppercase. And then we can do everything to title case. And I like title case because it changes the first letter of each word to a capital letter. So these are different ways that we can transform our data, our text data, so that way we get a consistent look. Commonly, what we'll do is before we actually start to process large volumes of data, we'll convert it to lower case so that way capitalization doesn't cause an issue. And we'll see later how capitalization could actually create some scenarios. All right, in our last lecture, we talked a little bit about stemming and lemmatization. So if you guys recall, we did lemmatization by using some sample words. We wanted the word text and the lemma, right, for our lemmatization. If you guys recall, this is kind of what happens when we apply that. So if we wanted just the lemma, right, so then we would take those sample words and put those in there and then just look at the lemma. And as long as that word is not punctuation, right? Right, so now we get just simply the right-hand column, which is the lemma words, right? All right. Here is the function, by the way. So if you get text, and like I said, I'm really hoping that you'll learn how to use our functions and then start to create like a small pipeline that you would use one function on text, then take the output of that, put it into another function and apply that and so on and so forth. So if you're going to do some lemmatization, here's a function that you can put into your pipeline, right? And what I do inside this function is I go ahead and insert my NLP tool right away, and I go ahead and apply that text, right? And then I am going to apply our lemma words, and if that word lemma is not a pronoun, else we're going, if it is a pronoun, then we actually want that word that is the text for that word, a text. What this does is it allows us that if we have John Doe, or actually, how should I say this? Let's say that we had let's say Mr. Jumps, right? It does, and we wanted to make sure that if it's a pronoun, that we don't change Mr. Jumps to Mr. Jump, right? So my system keeps crashing. His crashed yesterday. Our day crashes daily. Let's run it. So my system keep crash. His crashed yesterday. Ours crash daily, right? And notice the past tense of crash hasn't changed. So I noticed this with spacey lemmatization. Sometimes these words you would think would go one way or not. And I think that the reason why in this case is that crashed can also have other meanings other than the past tense of crash. So I can't really give you that example off the top of my head, but so if we wanted to, we were going to have to make a custom application in order to make sure that if it's crashed, that it lemmatizes to the word crash. All right, removing stop words. We used removing stop words in the past using a couple of, we used spacey in our last example. This time, let's use TalkTalk Tokenizer. So we're going to go ahead and instantiate a TalkTalk Tokenizer. All right, and we're going to get the stock word list from NLTK. By the way, this stop word list is nothing more than a list of words or a list of stop words. All right. All right, so here's going to be the text that we're going to process. And this right here is the entire function that is being used to remove stop words and then return to you a completed sentence, right? And this is going to make sense shortly. So first of all, we have to tokenize that text. So we're going to be actually using the TalkTalk Tokenizer, and we're just going to use that TalkTalk Tokenizer that we established on line 4. We're going to tokenize it. We're going to do a strip for every token that's in the tokens. And if you guys remember, or maybe this is the first time you've seen it, strip means remove all the leading and trailing spaces that might be in a string of text, right? And by the way, I have a flag here that says by default, if I want to convert everything to lowercase, right, I can set this to true. Otherwise, it's going to remain false. And we can see some different examples. And the stop words we're going to use is the stop word list. And that's actually what's listed here on line 5. So if it's lowercase, that means this is equal to true. It is going to filter everything out, token for token, if token is not in stop words. Okay. Otherwise, if it's not, we're going to filter the tokens for token and tokens if the lowercase value is not in stop words. And then line 16 puts everything back together and it spits out the filtered text. Now, all those little pieces you don't have to remember. You can simply copy and paste this over and over again. So let's see what it looks like. So we removed our stop words. We had stop words computer. So that means the, and, if, are, is not get removed. Now, by the way, let's go ahead and apply something here. Let's say is underscore lower case, and let's just set this equal to true and see what happens. And notice that the word the now remains because it doesn't match to a perfect lowercase stop word, because all the stop words are in lowercase. So this would be helpful if somebody's name is a stop word and it's just capitalized properly. So but of course we know that with Spacey we can just say don't remove pronouns. NLTK doesn't quite have that option. So NLTK type of tokenizing and removing stop words is this method. However, with Spacey, we're going to use our NLP tool to once again apply the text, and we are going to get the text for each token and tokens. If that token is not a stop word or its lemma is equal to a pronoun, and it puts it all back together. It's a little bit cleaner this time, right? So this big function this little function replaces the bigger function from up above. And this is what happens when we use different tools, right? So that's Spacey. All right, we can create some custom stop words. I have some examples here. This is actually a function that I created. It's very complex, but let's start with this my words. And right now what I've done is let's say that I want to process our stop text, into what I have here as default. Okay, let's take a look at what happens. All right, so what happens is that it looks at each of these words that I have, and it's going to actually, for every word in my words, I want to look to see if the NLP Spacey library recognizes those words as stop words. And what it does, it returns a false and a false. Okay. So now what I want to do is, okay, if it's currently false and I apply my remove stop words function that we have here, we can see that the result is stop words and computer. All right. So now let's say that I want to create a custom stop words. All right. So I've got this custom stop words, and let's say that I want to take my words and then add them to the current list. So add, I now need to make true. So this is actually going to add these to my custom stop word list, and then I'll run everything through and checking each word that is in my word list. We can see that now it is seeing them as stop words, and when we run our stop words with spacey function, we can see that there is nothing left. All right, but I really don't want that to happen. I'm going to change this back to false and run it so that way that stuff happens or is undone. All right, so if you really want to look at how this is done, we can say we can get the spacey stop word list like we did before. We can add a new word called true, and then we have to we can test to see if it's a stop word. So let's go ahead and execute this. We can see that the word call was added, and so it's true that it was a stop word. Now let's change this to false, and now we can check to see if that is a stop word and it's false. Okay, so by the way, this is not this creating custom stop words list is not something I'll ask you on a test or ask you to complete, but it is something I thought would be helpful for you to know in the future. All right. So we're going to go over assignment 3 during class, but in assignment 3 that I'm going to ask you to create a function that will use these functions up above to be able to do each of these tasks. All right. I'm going to recommend that you basically reuse some of the stuff that's in this lecture to create that one function. All right. So we'll cover that in class, and I will see you then. Thank you very much.